So some of the key concepts with quadratic functions, this idea that, and this is with any functions, that the graph, the function equation, and the table are all interconnected. And if we have some points on the table, we can often get an idea what this parabola is going to look like, and we can algebraically solve for the function equation. So one thing that is important to always remember is that, in the very useful tool, is that you can always substitute x and y pairs into the equation because they have to connect the three together. And we use this often with these quadratic problems because we're trying to solve for unknown parts, the coefficients a, b, c, or the graphing form a, p, q, or even the factor form, we have the a, m, and n. And we can substitute x and y points that are known to be able to solve algebraically for those unknown parts. So what's really important is the key parts of the parabola. And I'm going to just highlight A because that is by far the most important point. Okay, that is our vertex. Okay, so I'm just going to do this in a different color. So A is the vertex. Okay, and it's particularly important because it's not just a regular coordinate, it is actually identifying the axis of symmetry, which tells us basically to double the information of any other point. Okay, so the vertex is by far the most important point. So B represents zeros, and the zeros are nice because they are symmetrical. They also indicate some symmetry. Okay, so if we know the symmetry, we can find the other zero, or if we have two zeros, we can find the axis of symmetry. And C represents probably the least important point, but it is the easiest to find when we have the general form equation, and that is the y-intercept. Okay, so those are the key parts of the parabola, and we also have this axis of symmetry, but the axis of symmetry is essentially connected to the vertex. So the three forms of the quadratic function are the general form, graphing form, and factored form. Okay, so for the general form, really we get the a value, which is an expansion compression. Maybe I'll just write that out. Y equals ax squared plus bx plus c. And really the general form, as all forms, it gives us the a value, which is the expansion compression factor. Okay. And it also tells us the c value, which is the y-intercept. And so this is probably the least useful form. The most useful form is probably the graphing form, because the graphing form gives us the coordinates of the vertex. Okay, and most importantly, the p value. Okay, so the a value is still the same. The a value, this is still our expansion and compression. Okay, but this represents the coordinates of the vertex. So when we have the opportunity, we want to probably try to put it into graphing form. And finally, the factored form is very useful as well because, again, they all give us the a value, the expansion compression. Okay. But this gives us the roots. Okay, so these are the roots, or the zeros. And this, although it doesn't give us directly the symmetry, the axis of symmetry, it does indirectly give us the axis of symmetry because these are symmetrical coordinates. So any two symmetrical coordinates, we just need to find the middle to find the axis of symmetry. So how do the key points vertex, zeros, y-intercept relate? to the different forms of the quadratic equation, quadratic function, okay, we know that we have our y-intercept comes from our general form, the vertex comes from our graphing form, and the zeros come from the factored form. And so we also want to connect this idea that the functions, factors, and equations are connected, and they're essentially connected through the zeros, because in factored form, we can come up with the function, and we know some key parts of the function, in fact the zeros, and we end up with symmetrical points on the function. Later on, we're going to solve for a quadratic equation, solve for x, and the factors are where the zeros are on the function, okay, where the graph crosses the x-axis. Maybe I'll just sketch that here. Okay, it is through these 0 points that these three concepts end up being connected together. Okay, so our quadratic equations that we solve later on, we're going to solve them partially by factoring. Okay, and we can solve them also by graphing and seeing where they cross the x-axis. So another really important key idea, and we've already talked about this before, is this idea of symmetry. The symmetry is through the vertex. And that is very important because the most striking thing when you look at a parabola is the symmetry. And if you know where the vertex of a parabola is, you have a very good idea of the shape of the entire parabola. Okay, so we want to find any symmetrical points. Okay, so if we have the vertex, we can find any symmetrical point. So if I have the vertex and I have a coordinate here, I know the symmetrical point must lie equidistant from the center. Okay, it's going to be the same distance to the left as it is to the right because of the symmetry of the graph. And we can find the middle point, or we can find any of the exterior points using this formula. It's basically the formula to calculate average. x1 plus x2 divided by 2 gives us the center, which is P. Okay. So if we also have symmetrical points, for example, the zeros, if we have the two zeros, we can actually use this to find the center. So it works both ways. We can use the center to find symmetrical points, or we can use symmetrical points to find the vertex, or the axis of symmetry, and that's very important.